Hi everybody, this is Notes 45. So we started today by filling out this section. So see how many you know off the top of your head and then use your calculator for the rest. So take a second, pause your video, and then go ahead and fill this out. Come back when you're ready. So you should have your chart filled out here. I added a couple here. 2 to the 5th is 32. That can be really important to know. And 2 to the 6th is 64, and then 3 to the 5th is 243. So those can be super ones, important to know. A couple of these are really important for the ACT. The ones that I'm circling, the ACT loves to use these ones. So if we know these ones sort of in our head, it can be helpful to us later. So including these ones here, sorry, I can go ahead and circle those too. So today we're going to use the property of equality. Property of equality just means what we do to one side, we have to do to the other. So what all this math terms means is that if 3 is the base, then the exponents have to be equal as well. So if 3 is equal to 3, then x must also be equal to 5. So we would say in this case x equals 5. Similarly, if you add 2 to the 10th power equals 2 to the x, then we could say that 10 equals x. That just makes sense. Right? So when we look here, we have our 3 steps. We're going to rewrite each side of the equation so the bases are the same. We're going to set the exponents equal to each other, right? Basically means like cancel out the bases. Cancel the bases. That's what's happening right here. And then solve for the variable. So our first step is to rewrite it so the bases are the same. Here I see that 3 is the same as 3, so that's awesome. That means that we can cancel out the bases, and we're just left with x equals 5. And that is our answer, right? For this one, we want to make the bases the same. So I see a 2 and an 8. So the common base between them, right, I see 2 to the x, and then I know that 8 is 2 to the 3rd. I can go back to my chart here, and I can see that 2 to the 3rd is 8, and I want my base to be a 2. So I see 2 to the x is the same as 2 to the 3rd. I took the 8, turned it into 2 to the 3rd. That means that I can cross out my bases because they are the same, and I have x equals 3. As we start to move forward, we can continue to see what happens when there is an exponent. So we have 2 to the x power. Right? And then I know that my 8 is going to turn into 2 to the 3rd because we just did that problem last time. But this 3 is still chilling around, right? It's still on the outside here, right? So my 8 is 2 to the 3rd, and then that 3 from before, let's see if I can clear that up a little bit here. So the 8 is the 2 to the 3rd, and the 3 is this guy right here. So I have 2 to the x, and then I have 2, and I think, oh, I have 3 parentheses 3. That means 3 times 3, 2 to the 9th power. That means in this case I can cross out my 2's. I get x equals 9. For number 4, I see a 9 and a 3. So I'm going to go back to my chart. I'm going to look where I see 9's and 3's. So here in this section here, I see 9's and 3's. I see that 9 is 3 to the 2nd. So I'm going to say, okay, 9 is changing to 3 to the 2nd, and I still have my exponents, so 2x minus 1. I have my equal sign, and then I see 3 to the 6x. Right? I know that I need to multiply because I see my parentheses here, so I'm going to do 2 times 2x, so I have 3 to the 4x, and 2 times negative 1. So I have negative 2 equals 3 to the 6x. I see that my bases are the same, so I can cross them out. I'm left with 4x minus 2 equals 6x. Need to get the x's on both sides, so I see a 4x here and a 4x and a 6x there. So I'm going to take minus 4x and move it over here. It gives me negative 2 equals 2x. I am going to divide by 2 on both sides. That gives me x equals negative 1. That is my solution for this problem, for number 4. So that is our equal signs. If we have equals, that's how it works. It's going to work in the exact same way when we turn the page and we see inequalities, right? So inequalities is the exact same thing. If we have 3 is less 3 to the 1 power is greater than 3 to the x power, then we know that 1 is greater than x because we can cross these out here. Same is true if it's facing the other way, or if it says equals under. If we have 3 squared is less than or equal to 3 to the x power, then we would know that 2 is less than or equal to x, just like that. So we're going to solve this in the same way. So I see that my bases right now are 16 and 8. I know that those have a common base of 2 because I can write 16 to the 2 power. 16 is 2 to the 4th power. And I'm going to write the 2x minus 3. And then I know that 8 is 2 to the 3rd power. Right? So my 8 is turning into 2 to the 3rd. 16 is 2 to the 4th. That means that I have here, I'm going to distribute, as I start my problem, distribute in here. So I have 2 to the 8x minus 12 is less than 2 to the 3rd. I see that the bases are the same, so I'm going to cross them out. And that is going to leave me with 8x minus 12 is less than 3. Right? I'm going to rewrite it here so I have a little more room. Is less than 3. I'm going to add 12 on both sides. Gives me 8x is less than 15. Divide by 8 on both sides. I get x is less than 15 over 8. If you like decimals, you can write x is less than 1.875. Do that on your calculator. All right. So basically the same thing. We're just using the less than or greater than signs. So let me see if I can zoom in on this one here. Nope. Okay, guess not. Okay, so for this one, I see this fraction deal. And let me see if I can make this bigger. You can do it, little dude. Nope, maybe not. Okay. Well, okay, here we go. So we have this problem here for number 6. So for number 6, we see 3 as a base. Can I write on it? Nope. Okay. Pause. Go away. Guys, this is tough. Okay, here we go. So we see 3 as a base and 243 as a base. So I know that 3 is just 2x minus 1. And then I have a less than or equal to. 243 is 3 to the 5th power. I check that on my calculator. 3 to the 5th power is 243. So I know that that's that. But I see that it's a fraction. In order to make a fraction, I would need to say that it would be 3 to the negative 5. Anytime we have a negative exponent, it's going to make it a fraction, right? So we'd say fraction. That's just a side note. So this 1 over 243 is turning into 3 to the negative 5th power, like that. So then we can cancel out our 3's. We're left with 2x minus 1 is greater than or equal to negative 5. I'm going to add 1 on both sides. 2x is greater than or equal to negative 4. Divide by 2. X is greater than or equal to negative 2. That would be my answer there. Finally, we have our last couple of problems here. I can't see number 7. Come back. There we go. Number 7. So we have number 7 here. I see 32, right? Again, I know that 32 is 2 to the 5th power, but it's a fraction, so I need 2 to the negative 5th power. I'm going to have less than, and I have 2x plus 2, like that. I see the same base. Cross it out. X plus 2 is greater than negative 5. Subtracting 5 on both sides, or 2 on both sides, x is greater than negative 7. And then finally for our last problem, 625. I know that 625 is 5 to the 4th power, so this must be 5 to the negative 4th power. is less than 5, 3 minus 2x. My bases are the same, so I have 3 minus 2x has to be greater than negative 4. I'm going to subtract 3 on both sides. Negative 2x is greater than negative 7. Divide by negative 2 on both sides. It means that I have x is now less than, I have to switch the sign because I divided by a negative number. So I have to switch the sign. So x is now less than, these cancel, 7 over 2. Right? Or x is less than 3.5. And that is my work for today. Thanks, guys.